Ready, action.
Hello, boys and girls. Today we're going to talk about density, and this is a lab that we normally do every year on density, and it's called Density of Solids Labs, and we're going to collect the data, and then your chemistry teacher will work on the calculations with you. So this is the handout that we give, and we'll show you up close in a minute what you fill out, okay? And we have, and I'm gonna write them in, we have 4 types of metals, right? We have iron, we have brass, which is a combination, Mr. Iwan, copper and brass is copper and zinc?
Copper and, brass is copper and, yeah, I think it's copper and zinc.
Copper and zinc.
Yeah.
Bronze is copper and tin, right?
Yeah,
so
that's
brass
right.
is copper and
Yes.
zinc. So this is an alloy. And then we have just solid copper. And we have a piece of solid aluminum, right? These cool aluminum cylinders. All right, so let's just do the metals. And then we have 4 different woods. We'll get into that in a minute. So, as you guys have learned by now, hopefully density is defined as mass divided by volume. So to get to the density of these objects, we need to measure the mass, which is the scale, and we need to measure the volume. Okay, so that's all we're going to do in this lab is measure the mass and volume. Oh yeah, thank you, sir. Yeah. While he's writing that down, so mass and volume, and then in class we will calculate the densities, and we'll see how close. This is the first lab that I'm doing. Maybe Mr. Iwan's done one before this, but this is the first lab that I do during the year where we compare the results to a standard. And we'll see how close me and Mr. Iwan get, see if we're good lab workers, how close we get to the standard. In other words, the accepted value for the density of aluminum, and we'll compare it and see how close. Now in a normal class situation, you and your partner would do this, and after we do the calculations, you would see how close, we'd compare it to how close you get to the standard or accepted value for the densities of these objects, okay? All right, so let's start with the metals. Okay. You wanna do it up close to this real quick, and I'm gonna write on there, so.
So this is what the sheet looks like. Here, actually, why don't you
Edit it out or something.
So
Okay, so what we're gonna do real quick is right here. This is the data table for the metals. Oh, this is the data this is the data table for the metals. So you can see right here. Oh, up. It says mass of metal object. So we're just going to weigh the metal objects, and then we're going to get the volume by something called water displacement. You probably remember that from 8th grade. Most students have that, right? So we're going to write down the volume of the water in a graduated cylinder, and then put the metal in it, and then write the new volume. Okay? And then the difference in water levels, right? The amount that the water rises is the volume of the metal, right? That's called displacement, right? So, for example, when I move back into this air right here, the amount of air that got displaced is the same volume that my body takes up, right? And same thing with water. If we stick something in water, the amount of water that gets displaced is the amount of volume of the object that was put in the water. All right. Good? Okay, so the first metal we're gonna do, we'll go across, we'll do aluminum, and then copper, and then iron, which is Fe, and then brass. Okay, so that's the order we're gonna go in, all right? Aluminum, copper, iron, and brass. And we're going to fill these out, and we're going to show you how to do it. Okay, and then the calculations we'll do as a class later on. And then the back is for the woods, and we'll talk about that in a minute. Okay. All right, let's do the metals. All right, so first one, aluminum. I'm going to put it on the scale, right? Zero out the scale, make sure there's no junk on there. And the mass is 17.81. 17.81 grams for the aluminum. All right, so let's find the volume. Oops. So, wow, my eyes are getting old. What is that? 20, 10. You might want to. Yeah. Oh, 45, right? Can you verify that? About 45.
Yeah, it's about
What is
40.
that? What is that, Sonny?
Yeah, it's 46.
It's 46.
46.
Oh, jeez. All right, 46. So there's 46 milliliters of water in here. Just going to write down 46, and then I'm going to gently, so none of the water spills out, drop the aluminum in there. Okay, and it went up to. I can't read it again. Where's it going?
All right, son.
Let's come over here.
Okay.
Was that? Was that 40?
50.
52.
Yeah, say 52.
52? All right.
52.
So 52. So it started at 46. It went up 6 milliliters. That means that the aluminum, its volume is 6 milliliters, right? The amount of water that went up is the amount of volume. I'm getting water all over everything. All right. Paper towels?
Oh.
Over there. I got it.
Close. Okay, here we go.
So there's the aluminum, just so you can see what it looks like. All right, I dried it off. All right, so the next metal we're going to do is pure copper. So this is a kind of a solid copper rod.
And it looks
Right
like
cylinder?
copper. It has a, yeah.
Yeah. Okay.
Yeah.
You get that nice copper color.
Yeah.
Okay. So let's see.
Kind of like a penny, right?
Yeah.
And right now everyone's saying, what's a penny?
Yeah, I know. The coins are gone. Okay. So I'm going to weigh the piece of copper, right? So mass, that one is 78.70. So 78.70 grams. All right. And then, you know what? I'm going to put this aside. I'm going to do the volume in a minute. Let's go on to the iron. Okay, this is an iron bolt that they use standard in, construction stuff. Down.
Yeah, there you go.
Okay, there we go. All right. So I'm going to weigh that guy. Let me zero out the scale. Put it on there. All right, 68.79. All right, and then the brass, right, which is an alloy of copper and zinc. So there's a brass bolt. They use them in construction and up. All right, building stuff. Okay. Okay, we'll put these in here. 74.59. All right, so those are the weights. Oh, and by the way, make sure that you use the same piece for your mass and volume readings. Don't use a different piece of brass for your volume. It doesn't work that way. Okay. All right, so anyway, I'll do the brass next. I'll go for volume. That way I don't have to keep doing this. All right, so, here we go again. Oh, I can read this now.
Can you read
That's
it?
53. Okay.
All right.
So we got 53.
Mr. Smith needs to eat more carrots.
I do, little side note, juicing beets and carrots does help your eyes.
Does
I've
it?
noticed it, yeah.
Oh,
My
there you go.
eyes are sharper, so
Wow.
definite recommendation.
Okay. There you
Try
go,
to get
kid.
organic fruits and vegetables only. But
There you go,
you
kiddies.
can. There you go. All right, so brass. Oops. We're going to use it anyway because we're short on time. That water that spilled out, we'll just have to make it.
I don't think it was that much. I don't think
Okay,
it'll.
so we're up to. Man, it's just the clearness of it. Oh, we're up to, that's 60. Okay, so it went up 7 milliliters. Probably more like 61, but spilled it. So I won't be surprised if when we calculate the density of this brass, we're away from the standard value because of my little mishap there with the water. Okay, and that's another thing. When you do lab work, right, you want to start looking at things that might cause your results not to be so good, right? So that was an obvious one, spilling the water. All right, so let's go to the iron bolt. All right. Okay. All right, so we're starting this time at okay, 40, 46, 47.
46.
Okay.
It's like about 46.5.
Okay, we'll do 0.5 on that one, 46.5. Okay, so that's for the iron bolt, 46.5. So now I'm going to drop it in gently. Man, this now I have a little more respect for when the students do it. Okay, yeah, all right, so now it's, all right, I got this. It's the clear plastic that's coming out.
Maybe we should
10, 20, 30, 40, okay. 44, 44? Can you verify that? Oh no, it's way up here, I'm sorry.
Yeah, it's about
It's like 50,
55.
55?
Yeah, 55,
Okay.
yeah.
All right, so it went from 46.5 to 55. So there's, you know, the volume. All right. All right, and then last but not least, we'll do the copper piece here. All right. All right, you know what I could do?
It's what?
Hold it behind a black
Oh yeah, there you go.
backdrop.
Or a dark.
Dark.
Backdrop.
So that's 55. Man. Well, that's 60, so that's 10. 56. All right, so that's 56. All right, so here we go. I'm going to try it this way this time. There we go.
There
That's
you
the way to
go.
do it. Okay. And now it's 66. So 56 to 66. Okay? All right. Not having that water spilled out, I realize just made a big difference. But oh well. I'm not gonna, okay. All right. So we got the masses and volumes of our metal pieces. Now it's time to do the woods. Okay? So make sure to dry these off, especially the iron bolt, because remember, iron rust pretty easily. So
Do it. Yeah. Okay. Yeah. Okay.
okay, so you can see the data I recorded in my wonderful handwriting, but oh, there you go. Okay, so that's all the data. Now we're going to do the back, right? And we're going to do 4 woods. Okay, so let me write them down. We got pine. Pine is fine. Pine wood. Pine is fine.
That's fine. Okay, so I can write them on the board too.
Oh yeah. Okay.
So pine.
And then spruce willis. All right, spruce. Block of spruce wood.
Pine. Spruce.
Spruce Lee. What other famous spruces are out there?
Spruce Willis.
Spruce willis, yeah. And then we got oak. Right. Had a student a couple years ago named Oak Lee. So that's his wood.
Oh, that's a.
And it was
That's a great
spelled
name.
A-O-K-L-E-Y.
A-okay.
Oakley Spence, yeah. He graduated last year, I believe.
Oh, Oakley.
Like Oakley.
Like as in Annie.
Annie Oakley, right, but that was his first name. And then we got a cylinder of wood. This is fir, F-I-R. This is fir wood, okay? Okay, you can see that. All right,
So these are blocks.
these are blocks and one's a cylinder, right? Okay, so we're gonna take the masses of each wood by weighing it. And then for the pine, the spruce, and the oak, maybe make sure this is focused. Just, are we good?
Yeah. it's
Okay, so you got the 4 woods: pine, spruce, oak, and fir. Now with all the 4 woods, we're going to weigh them, And then with the pine, the spruce, and the oak, we're going to measure the length, the width, and the height. Okay, in millimeters. Okay, for the fir,
Yeah, fir is a cylinder, so it's going to be, how are we going to do the...
so we're going to do, we don't need the length and the width, we're going to do the height of the cylinder and the diameter across the top.
Yeah.
And then we'll plug it into these equations here.
Right here.
Right.
Pi times r squared times the height
Right.
is the volume.
And that'll give you that's how we're going to get the volumes for the woods. We're going to use math instead of water displacement. Okay, so it gives you a good example of different ways they can measure masses and volumes of things. All right.
All right.
So first, let's weigh them. All right, so here we'll go with the fir first. We'll just weigh it. It's 25.79 grams. Okay, the oak, let's zero that out. The oak is 41.51 grams. Okay. The spruce willows is 48.13 grams. And the pine is fine. All right. Okay. All right. We'll weigh the pine here, and that's 63.14 grams. Okay, so we got our weights of our woods. All right, so now for the pine, the spruce, and the oak, we're going to do the 3 dimensions, right? Length, width, and height. Okay? Or as I tell the students sometimes, put it in front of you and just remember up, over, and out. Okay? All right, now
Does it matter which side is height, which is width, and which is length?
no, because you're going to multiply all 3 of them together. So,
Okay, that's a question I always get.
yeah, it does not matter. And real quick, we're going to measure in millimeters. So never inches. So millimeters are each little line. So that right there where my thumb is would be 10 millimeters, right? And then there's 20, 30, 40, 50, and so on.
Okay,
Right?
yeah.
Okay. All right. So the pine, okay, so up, over, and out. And it doesn't matter where, as long as, as long as you record the 3 dimensions, because we're going to multiply them together to get the volume anyway. So let's go up first. That's 18 millimeters. We'll call that height. All right, then we're going to do over or across. That's 110 millimeters. And then out, right? So up, over, and out. And that's 54 millimeters, okay? All right, so we've taken care of pine. We can put him back in the box. All right, so let's do spruce moose, spruce goose. All right, spruce moose is a Simpsons thing. You guys are way too young for that one. It's like 1995 or something. Anyway.
They weren't even born then.
Yeah, isn't that crazy? Never thought, yeah. Anyway, all right, so again, put it down. Well, I'm gonna do up. So up is 77 millimeters. We'll call that the height. Okay, over is 35 millimeters, or 3.5 centimeters, right? And then out, it's probably about the same. Yeah, we'll give that one 34. Okay, 34 millimeters out. Okay, or 3.4 centimeters. All right, that's good. All right, let's go to oak. Same thing. Up is 1.7 millimeters, or centimeters, so 17 millimeters, sorry. So 17 millimeters or 1.7 centimeters. Let me double check that, yeah. And then over is 77 millimeters. And then out, right, is 34 millimeters. Okay, or 3.4 centimeters. All right. And last but not least, the fur, right? We're going to just measure the height and the diameter, right? And that's all the dimensions we need. And then we can do the calculations to figure out the densities of all these, all right? So the height on this guy is 4.4 centimeters, so 44 millimeters. And then the diameter is 30 millimeters, or 3 centimeters. All right? Those are the measurements. All right? And that is all I got to say. So we will, in class, do the calculations. And you can see, and we'll see how close we get to the accepted values, which is on, you know, a chart. Okay? We'll see how well me and Mr. Iwan did in our lab work. Okay? But any last words, sir?
No,
I think that's pretty much it. So, so it's a simple density lab, but it's very important. This is how they test for densities for like precious metals and stuff. They weigh it, drop it in water, take the mass and volume, divide it, and if it's the correct density for gold, then you know it's gold. If it's not, then you know it's what, fool's gold or something, or an alloy. Or,
Yeah. Okay.
all right.
Good. Okay.
Thank you very much.
Thank you.